Alright, so we're going to be starting with translations today. So again, the idea of a transformation, when we were talking, or when the video was showing you the different forms of transformations, a transformation is just a geometric operation that's going to transform an image. So it's a geometric operation that transforms an image. Sometimes they might be able to maintain orientation, which means that the way that it looks in the exact direction that it's looking. Other times it might flip or rotate its orientation. Sometimes transformations will even change the size of a shape. So that's one thing that the video did not discuss. So we're focusing today on translation, okay? And a translation is just the sliding of a figure. So another word to say translate is to slide. Okay, another word for translate is slide. So you're going to slide a figure from one position to another. Translation is just sliding a figure from one position to another. So now, one thing that's really important to make sure you understand is the original image is congruent. It is congruent to the translated image. And again, what does congruent mean, guys? What's congruent mean? Equal, right? It is equal. It's unchanged in its size. The size of it is still equal to its original. So the original image is going to be congruent to the translated image. All right, another very important key piece of information is this is the only transformation that maintains not only size, but it also maintains orientation, which means the direction that it's facing. That's very important to know. A translation is the only, and I'm going to put that in big capital letters, and I'm going to underline it too. It is the only transformation that maintains not just the size, but the orientation. Okay? A reflection will maintain size. A rotation will maintain size. But none of those will actually maintain their orientation. The direction that they're facing would change. With a translation, size and direction are going to be the same. So essentially, it would be like, okay, if I take this piece of paper, translating it would be to just move it. That's it. It's still facing its same direction. You can see it. If I were to rotate it, it's not facing the same direction. It didn't change its size or anything else, but it's not facing the same orientation anymore. If I were to flip it, which is kind of hard to do, but like a mirror image, then everything would be backwards. You know, flipping it, if you can see through it a little bit, that's what the flip would be. Okay? So, again, a translation keeps everything the same about the shape. It's just in a different location. So, here's an example. If I take the following shape, and I'm going to label it A, B, and C. And now I want to translate it. So I want to go ahead and move it to the right. Well, when I move it to the right, again, everything about that shape is going to stay the same. This is still A, but now because it's translated, it's called A prime. This is important. You have to put that little notation. That notation means that it is a transformed shape. This is A prime. This is B prime. This is C prime. That little apostrophe there is called a prime. Now, let's say I move it again. If I move it a second time, again, the shape is going to stay exactly the same size, same position, but now this is a double prime. I have to put 2 apostrophes. This would be B double prime. This would be C double prime. Okay? So, one transformation is called prime. A single transformation is called prime. A double transformation means that you had 2 transformations, like 2 translations, or a translation and a rotation, or a rotation and a reflection, or a reflection and a dilation, or maybe a reflection and a translation. When you have more than one, so 2 transformations, we call that a double prime. And if we had 3 transformations, it would be called a triple prime. Okay, so it just keeps going on. You've got prime and double prime. We typically don't do more than 2 transformations, currently. Another thing that's really important to know. When you are translating, so the concept of translating, again, is going to cause you to move from one position to another. So for translation, if it indicates that you're going to move to the left or to the right, a move to the left or to the right will have an effect, or it will change your X value. So if you're talking about a coordinate grid graphing, and you're given a point, remember points are labeled X, Y. When we move from the left to the right, or from the right to the left, it changes the position of our X. It changes the position of our X. Now, if we move to the left, we would be subtracting from our X value. When we move to the left, we subtract from our X coordinate. If we move to the right, we would be adding to the X coordinate. So if I say, oh, we're going to move left 2 positions, then whatever my X coordinate is, I'm going to take that value and subtract 2. If I say we're moving right 7 positions, then I'm going to take that X coordinate and add 7 to it. That would let me know what my new coordinate would be. I could also move up or down. So if I move down or up, that's going to have an effect on what? The Y. This will change your Y value. A move down or up is going to change your Y value. So if we move down, we would be subtracting from our Y. And if we move up, we would be adding to the y. If we move down, we would subtract from our y. If we move up, we're going to add to the y. And again, just as a reminder, our coordinates are written as x, comma, y. That's our coordinate. Okay, take a moment to get that finished down and then go ahead and turn to page 56. Alright, so on page 56 of the notebook, let's go ahead and take a look at a few practice problems. So if I have point A, and point A is at coordinates -3, 4, and then I've got point B that's at coordinates 1, 3, and then I have point C is at coordinates -4, 1. So these are my coordinates for my points. And I want to go ahead and indicate that I'm going to translate. We're going to translate 2 to the right and 5 down. I'm going to translate 2 to the right and 5 down. Now I know this looks like it's going to be 2 translations, but it's actually one translation that's happening, because 2 to the right and 5 down is a diagonal move. Translations don't just have to be to the right, to the left, up, or down or up. It can be a diagonal move, and a diagonal move is a combination of right and down, or right and up, or left and down, or left and up. So it's considered still to be a single translation here. Okay, so we first want to go ahead and identify our different movements. So the first movement that I have is going to belong to the x. So I'm going to go ahead and highlight that in blue, since I indicated my x moves in blue on the previous slide. So I'm going to translate 2 to the right. Because I'm going to go to the right, that means I'm going to add 2 to my x value. Okay, for point A, which one of those numbers is my x value? -3. Guys, go ahead and just share it out. Don't be shy. My x value is my -3. So I'm going to add 2 to that -3. And by doing so, my A prime, the x value is now going to be at what? What's -3 plus 2? -1. So my new A prime x coordinate is -1. Okay, I'm going to do the same thing for my B coordinate. I'm going to add 2. And with my B coordinate, what's my new x value? 3, right? 1 plus 2 is going to give me 3. And then I'm going to do the same thing for C. My x coordinate is the -4. I'm going to add 2 to that -4. And my C prime coordinate for x is going to be what? -2. Okay, so I just completed all of my translations for my x translation. Now let's focus on the y translation. The y translation says it's going to go 5 down. 5 down, which since I'm going down, that means I'm going to subtract 5. from my y. I'm going to subtract 5 from the y. Okay, so obviously these second values are all my y's. And away from each of them, I'm just going to put a minus 5 underneath them all. Minus 5, minus 5, minus 5. Okay, so for my a prime, what is my y coordinate going to be? Negative 1, right? 4 minus 5 is a negative 1. What about for b prime? What is the y going to be? Negative 2. 3 minus 5 gives me negative 2. What about for my c prime? Negative 4. Good. 1 minus 5 gives me a negative 4. Okay, and there's my final answer. A prime is at negative 1, negative 1. B prime is at 3, negative 2. C prime is at negative 2, negative 4. Go ahead and try that one on your own. All right, who can tell me what they got for x prime? Jair? Very good. Negative 2 and negative 1. Okay, and then what about for y prime, Devin? 5, negative 6. And then for z prime, who can tell me what they got for z prime? Go ahead, Eric. 1 and negative 8. Very good. So let's take a look at that. So here, translating 3 units down and 1 unit to the left. 1 unit to the left I'm going to highlight in the blue because that's where it affects my x. Now keep in mind, it doesn't have to always be written in order. Notice that they told you to do the y translation, then the x translation. So be careful about that. Y doesn't always, or x doesn't always come first and y second when they're talking about what they're going to do. The coordinate, yes, x and y has to be in order, but the directions that they're telling you to move doesn't necessarily always happen x, y. So be careful about that. 3 units down means you're going to take your y value and subtract 3. 1 unit left means you're going to take your x unit and subtract 1. So from each of my x's, I'm going to go ahead and put minus 1, minus 1, minus 1. Each of my y units, I'm going to put minus 3, and minus 3. So then when I'm talking about my x prime, my y prime, and my z prime, it's okay, I don't need that, thank you. Negative 1 minus 1 gives me negative 2. 2 minus 3 gives me a negative 1. So there's my x prime. 6 minus 1 gives me 5. Negative 3 minus 3 gives me negative 6. There's my y prime. 2 minus 1 gives me 1. Negative 5 minus 3 gives me negative 8. There's my z prime. So there's my newly translated figure. Okay, let's try something a little bit different. Let's say that we have the point F, and point F is at x minus 7 and y plus 5. X minus 7 and y plus 5. And I say we're going to go ahead and we're going to translate 6 units up and 3 units to the right. We're going to go 6 units up and 3 units to the right. So again, 6 units up, does that affect my x or my y? My y. That affects my y. So I'm going to go ahead and highlight 6 up in green to show that it's going to affect my y. And I'm going to even put y underneath it. Okay, and then 3 units right affects my, what? My x. Good, so I'm going to highlight that in blue, and I'm even going to put in a blue x underneath it. Okay? So when I'm looking at my point, I have x minus 7, and I have y plus 5 as my point, f. When it says I need to go 3 to the right, that means I'm going to add 3. So I'm going to add 3, but the only thing that I can add 3 to is this right here. Since it says x minus 7, that acts like it's a negative 7. What is negative 7 plus 3? Negative 4. So my newly translated figure is going to be x, right? That x is going to come down. And then negative 7 plus 3 gives me negative, so I put minus 4. That is my newly translated x coordinate. Okay, so this is now my f prime. Okay, now I need to do the same thing for the y. The y says it's 6 units up, so that means only thing that I can add 6 to is this number portion right here. Okay, that number portion, that 5 is a positive, so it's positive 5 plus 6. What does that give me? 11. Positive 11. So that y is still going to come down. And because this is a positive 11, I'm going to put a plus sign and then 11. So there's my newly translated f prime. Any questions so far? Okay, go ahead and get that copy down. And then let's get moving on to the last. All right, so page 57, problem number 4. We have point A is at negative 6, 2. And it's moving to A prime. A prime is at 12, negative 4. So I'm giving you the original point, and I'm giving you the translated point. So point A started at negative 6, 2, and when we translated it, it moved itself to A prime at 12, negative 4. What I want to know, what is the translation? I want to know what the translation was. Okay? So with a problem like this, we know that we're going to start at A, and we're going to end at A prime. We're going to start at A, and we're going to end at A prime. So what I want to know for x if I start at negative 6, right? I start at A, which is negative 6. Then I'm going to add some kind of value of x to get to A prime, to 12. I want to know what value did I add. So this is just an equation that you're going to have to solve. Instead of having a negative 6, what's the inverse operation here? Not subtraction, addition. Remember that positive, that addition sign belongs to the x. You're trying to get rid of that negative 6. because I want to get rid of that negative 6, we have to do the opposite of it, which is a positive 6. So we're going to add 6 to both sides. That's going to give me x equaling 18. Since 18 is positive, that means that we translated 18 to the right. 18 is how much we moved. To the right is because it was positive. Okay, let's do the same thing for the y. We started at a, so we started at 2. Then we add some value for y, and we ended at a prime, so we ended at -4. What am I going to do to solve here? Subtract 2 from both sides. Very good. You have to subtract 2 from both sides because 2 technically has an imaginary plus sign right in front of it, doesn't it? It has a little imaginary plus sign in front of it, and that imaginary plus sign is what we're going to do the inverse of. So we're going to subtract 2 from both sides, and that's going to give us y equaling -6. So since it's a -6, that means that we're going to translate 6 units, and since it's negative, it's going to go down. We translated 6 units down. So then our final answer is 18 right and 6 down. 18 to the right and 6 units down. I want you to try one of those on your own. If we have point X is at 2, -4, and we're going to go to X prime. X prime goes to -3. -1. I want you to figure out what the translation is. All right, let's go over this one. So for here, starting with our X, I know I'm going to start at 2. I have to add some form of X value to get to -3. So by doing so, in order to get X isolated, I'm going to subtract 2 from both sides. And that's going to give me X equaling a -5. So that means that I went 5 to the left. Because of the fact that it was negative, I went 5 units to the left. Okay, then for my y, I'm going to start at my y value, which was -4. I'm going to add some form of y, and it's going to end at my y value for the x prime at -1. The inverse operation here is to add 4 to both sides. And that's going to give me y equaling a +3. That means that I moved 3 units up. Okay, because the y, positive y, means it went up. Okay, so there is my translation. 3 units to the left, 5 units up. 3 units left, 5 units up. All right. Our last little example before I send you off on your own. If I have point A and it's at 2, -1, and I want to go ahead and translate 2 units up, 4 units left, And then I'm going to translate again. 1 unit right and 9 units up. I want to know what it's going to end up at. So if we're starting at the points 2, -1, I'm going to start first with my first set of translation, which we're going to call it prime. Okay, this is my first set of translations, prime. Now, 2 units up is going to affect my y, so I'm going to highlight it in green. 4 units to the left is going to affect my x, so I'm going to highlight it in blue. By going 2 units up, that means I'm going to take my y value and add 2. 4 units to the left means I'm going to take my x value and subtract 4. So coming over here at my original point, I'm going to subtract 4 from the x and add 2 to the y. And that's going to end me at a prime. A prime, so you have to put the a in the apostrophe for prime. 2 minus the 4 is going to give me a -2. -1 plus 2 is going to give me a +1. So there's where a prime is. But I have a second set of translation, don't I? So that right here is going to be called a double prime. So remember at the beginning of the notes I said that if you had 2 translations, that would be double prime. For here, 1 unit to the right, going to the right affects my x-axis. Then 9 units up, that's going to affect my y. So going 1 right means I'm going to take whatever my x coordinate was and I'm going to add 1. Going 9 up means I'm going to take my y unit and add 9. So to my a prime, I'm now going to add a 1 and then add a 9, and that's going to give me my a double prime. My a double prime. And a double prime, so -2 plus 1 gives me a -1. 1 plus 9 is going to give me 10. So there's my double primed value. A double prime is at -1, +10. There's my final answer. Okay, you do have homework tonight. You're going to be able to start it in class. It is due tomorrow. We will be checking it first thing when class starts.